maybe. I don't know, maybe. Okay, here we go. So today's date is May 4th. Star Wars Day. May the 4th be with you. So today what we're going to talk about is special parallelograms. Special ones, right? Rhombus, rectangles, squares. Rhombus, rectangles, squares. They're all basically parallelograms, okay? So what do we know about rhombus? So we're going to define it as this. It is a parallelogram. With 4 equal sides. Okay, so I think I have one here. Here's a picture of one on my template. And so that side would be equal to that side, would be equal to that side, is equal to that side. Now we know, obviously, that it is going to be a parallelogram. So all of the things that go along with it, you already know. Okay, so for instance, in a parallelogram, we know that opposite angles are equal, right? I don't need to write that down, right? We know that. We know diagonals bisect each other, right? We know that. We know that opposite sides are parallel. All the parallelogram things we know. But what makes it unique? Well, in our journal, we got a few new things, right? So what else is unique about it? Okay. So if I go back to my journal and take a look at it, we talked about a couple of unique things about a parallelogram, okay, or rhombus. Okay. So one of the things we know in a rhombus is this, that the diagonals are going to be perpendicular. So let's write that down. We also know that the diagonals are perpendicular. So if I drew in my diagonals, they are perpendicular, okay? We also know that they bisect, the diagonals bisect the angle. So that means that that angle would have to be equal to that angle because they're bisected. And that means this angle would have to be equal to that angle because it's bisected. I know that this angle here would be equal to that angle here. Same thing there. Okay. We already know opposite angles are equal because that's part of being a parallelogram, right? Opposite angles are equal. We know that from parallelogram. But what it does specifically is it bisects, cuts that angle in half. That angle got cut in half. That angle got cut in half, bisected, and that angle got cut in half. Okay? Thumbs up. Okay, now what about a rectangle? Well, it is a parallelogram where all angles are congruent or equal. We'll use the word equal. Congruent, equal. And if that's the case, they're all 90. They have to be, right? So, or they're all 90 degrees, right? Let me go ahead and draw a rectangle out. Clean up that notes right. You want to grab 2 of them just in case Axel comes back to. Here's the notes. Okay. So let me go ahead and draw a rectangle. I think I've got one right here. Here's my rectangle. We know we're going to put in our 4 right angles. It makes it a rectangle. And it has all the same characteristics as the parallelogram. Opposite sides are equal. Yeah, they're parallel. diagonals bisect each other, we know that. But there's something more unique about it. And in a parallelogram, the diagonals are congruent. So one, the diagonals are equal or congruent. Congruent is just another word for equal. When we use the word congruent, we're talking about shapes. It's just saying shapes are equal, that's all. So if I draw my diagonals, and if I label this A, B, C, D, we can say that AC must be equal to BD, okay? And again, I like the story that I did with Mr. Jones. He and I built his garage, and we were putting in the foundation, and I like the fact that he said, no, don't use Pythagorean's theorem. Just measure the diagonals, and you know it's going to be a rectangle. Okay? Now what about a square? Well, a square is a parallelogram, or it's either, I like to use this, it's a rectangle with 4 equal sides, which means it's a rhombus, right? Or it's a rhombus that's a rectangle, or it's a rhombus with 4 equal angles, which means it's a rectangle. So it's either a rhombus that's a rectangle or a rectangle that's a rhombus. Special characteristics of a square? Well, it has everything. You guys agree? I mean, a square has all of the parts. It has the characteristics of a parallelogram, all parallelogram characteristics. Okay. So, as you're writing, I'll talk about it, okay? So, parallelogram. Let me draw a square so you can see it. Got one on here somewhere. Where's my square? Where's my square? I have a square on here. Of course I do. Gotta have a square. Oh yeah, there we go. Here's my square. So if it's a parallelogram, we know that it's going to have opposite sides are parallel. Yeah, it's a square. Right? We know that. That's parallel to that. That's parallel to that, right? We know opposite angles are equal, right? We know that diagonals bisect each other, right? I agree with that. So I can draw my diagonals. All these things we know are true about a parallelogram. The square gets. Square gets everything, right, Scott? Isn't that what you said? Square is everything. Diagonals bisect each other. It's also a rhombus. So it has all the characteristics of a rhombus, right? Diagonals are perpendicular, and the diagonals are bisected, and it's also a rectangle. So we know it's got 4 90-degree angles, and so all the characteristics of everything above it, that's your square, okay? Pretty easy. You already know this. You learned this in middle school, didn't you? You guys, my 8th graders, you probably learned this in 6th grade or 5th grade, maybe, huh? Okay, ready to turn the page? Not yet, okay. Easy peasy. Natalie, you give me thumbs up when you get it. I'll be very patient to wait for you, okay? Glad you're taking notes. All right. Okay, let's turn the page. Okay, so yeah, example 1. All right, this can't be too hard. Find all missing angles of this. Okay, it's a rhombus. It's a rhombus. Okay, so what do I know? Well, the sides are all equal, right? So that's 9, and that's 9, and that's 9, right? It's a rhombus. Okay. Now, the angles are bisected. So if that's 42 degrees, that's also 42 degrees, right? And I know because it's a parallelogram that opposite angles are equal, so that's got to be 42 degrees and 42. Does that make sense? Now what I don't know is angle B, but what I'm going to do is this. To get angle B, I know 180 degrees minus 42 degrees. Nope, 84, my bad. 84 degrees, right? Because that's all of angle C. I know these two angles have to add up to 180. We learned that about parallelograms. So if I go 180 minus 84, what's that? 96, something like that? Yeah, 180 minus 84 is, 96. So angle C is 96, but I'm going to divide that by 2 because it got bisected, right? So I divide that by 2 and I get 48. So I'm going to have 48 degrees here and 48 degrees here, right? And then, because it's a all of 90, yes, it is. It is.
C is 84. Wait, sorry.
That's okay.
80, so angle C has the 242, so that's 84, right?
Right.
And then B is 96.
Yes. Yes. And because angle D and angle B are equal because it's a parallelogram, that's also 48 and 48, okay? And the last thing I know is that is 90 because it's a rhombus, right? How's that? Okay. Example 2. Draw rectangle ABCD. Well, I can draw. Okay, I'm going to draw a rectangle. I'm going to do that real quickly. Okay. I'm going to draw my rectangle in. I got my special templates. I like these templates, okay? And I'm going to go A, B, C, D. I'm going to draw in my diagonals, okay? I'm going to draw my diagonals. I do that there. And there's my diagonals. What do I know? Well, they're equal, right? I know the diagonals are equal, so I know this. AC, which is 2x minus 6, is equal to BD, which is a 3/2 x plus 1, okay? Now I have to solve for x. So you guys don't like fractions, but you like decimals, right? You don't like fractions, so why don't I just change that to 1.5x? You okay with that? I mean, instead of 3/2, 1.5, same thing, okay? And I'm going to solve. Okay, so I'm going to go minus 1.5x minus 1.5x. That gives me a 0.5x minus 6 equals 1. Plus 6 plus 6, 0.0, whoops. X is equal to 7. I go plus 6 plus 6. If I divide by 0.5, I should get 14. You can use a calculator, but you know. So if x is 14, then I'm going to take my 14 and plug it in right there, right? Plug it in right there because I need to find the length of the diagonal. So I'll go 2 times 14 minus 6. 28 minus 6. What's that? 12? 22? So my diagonals are 22. And the other one's also got to be 22 because they're equal, right? Thumbs up. Okay, now, example 3. We've got to do a proof. We've got to figure out why this thing is what it is. Okay, so let's graph it. -4, -1. A. -1, 5. 1, 2, 3, 4, 5. There's B. 5. 1, 2, 3, 4, 5. 2. There's C. And 2. 1, 2, 3, 4. There's D. Okay, now, what is it? What's the best statement? Okay, is it a square? Looks like a square, doesn't it? What do you think? You guys think it's a square? What do you think it is? I think it's a square, but I'm going to try and prove it. So if it's a square, these angles have to be 90. How do I prove that? Oh, that's an interesting way to do it. I'm not against that way. I got an easier way, though. You're right, though, Tava. You're right. I'm going to do it an easier way, okay? If the slopes are opposite, then I'm going to have 90. I'm going to have perpendicular, which makes 90 degrees. You okay with that? Tava, you're totally correct on what you said. But that's just too much work for me, okay? How's that for an answer? So I'm going to do this. So I know the slope of BC is down 1, 2, 3, 1, 2, 3, 4, 5, 6. Down 3 over 6. But the slope of CD is up 1, 2, 3, 4, 5, 6, 1, 2, 3, up 6 over 3. Okay, those are opposite slopes, so I can say that BC is perpendicular to CD. Okay, you guys agree with that? Slopes are opposite, they're perpendicular. If they're perpendicular, it's got to be 90 degrees. I like that. So I got 90 degrees for angle C. Angle C. Okay, now what about AB? The slope of AB, well, let's see, that's up 6 over 3. Oh, yeah. And the slope of AD, that's down 3 over 6. Okay, I'll let you get caught up, but I'm just doing the slopes, which means all of these are perpendicular, right? If they're opposite slopes, you see that? So if they're all perpendicular, then if they're all perpendicular, if AB is perpendicular to AD, then what I've proven is that angle A is 90 degrees, angle B is 90 degrees, angle C is 90 degrees, and angle D is 90 degrees, okay?
Good morning, Kodiaks. We are ready for class of 2024, A through G. Again, class of 2024, A through G. Please head to the Commons with a computer for scheduling.
What was
Okay.
the process here? Why would you do the last and then the first and then skip stuff?
I don't know, just randomness, I don't know. Okay, now, you know what I've proven? I've only proved it's a rectangle. How do I prove it's a square? I got to see if these sides are equal, so I got to find these lengths. So I'm going to find out the lengths of these sides. And I'm going to use Pythagorean's theorem. Now check it out, okay? Do you see a right triangle? Guys see my right triangle? Do you see my right triangle in green?
Yeah.
So if I do right triangle, if I do my Pythagorean theorem, I have 3 squared plus 6 squared equals c squared. I have the exact same right triangle here, right? Don't I? I'd have another 3 squared plus 6 squared equals c squared. I have another right triangle here, so if I'm finding this length, I'd have another 3 squared plus 6 squared equals c squared. And I have one more right triangle right up here. I'm just using Pythagorean's theorem, and it would be another 3 squared plus 6 squared equals c squared. So all the lengths, let's see, let me do it. That's going to be 9 plus 36, which is 45. So the lengths of all of them is square root of 45, right? So if they're all square root of 45 as a length, 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 it's got to be a square. 90 degrees, equal lengths. I know for sure it's a square, and I proved it, didn't I? There you have it. Okay. So homework today. Let me go ahead and stop this. I've got a worksheet. Stop recording. Stop recording. Stop recording. Stop.